Hey guys, I'm Evan, this is Michael, and this is Deshan, and we did a solar panel analysis. Did you guys know that the US Energy Information Administration, they're projecting that world energy consumption will increase 56% by 2040. That's a huge number. Based on our current world usage of fossil fuels, we're gonna run out of oil in 2052, gas in 2060, and coal in 2088. So what's our solution? Using renewable energy sources, solar panels. The overall trend, as you can see from 2000 up into 2015, you can see a very large upwards trend. And the questions we had from our preliminary analysis: where are the solar panels being installed? Who's the target market? And are there any correlations between installations and variables from the census data? Things like age, income, location. So I'm gonna pass it off to Michael, and he's gonna talk about how we got there.
Hi everyone. So in order to answer those three questions, we had to pull in data from multiple sources, and we had to use a variety of different tools. We use an API to pull in data from the census, and we imported over 1 million data points from NROL. Some of the tools that we use a Google Maps API, Matplotlib, and Seaborn. For data visualization as our core, we use Python and Jupyter Notebook. And for statistical analysis, we used SciPy. So an overall view of our workflow: we imported the census data with API pulls. We imported the NROL installation open source data. We merged the data frames on the key zip code, and we used MATLAB, Seaborn, and GeekMap packages to create visualizations. So here's a sample of our code, and Evan will go more into this a little later in Jupyter Notebook. But here's our API pull. We imported all that data, and we saved it to a data frame. We imported all of our NROL data, and then we used a group by zip code count to some instances. And what this allowed us to do is create a weight for our heat map, which we'll show you shortly. And of course, we merged all that data based on the zip code. So what did we find? So in terms of the first question, which is where are solar panels being installed, it's clear as day, right? California is leading the pack with over 600,000 installations, followed by Arizona, Connecticut, New Jersey, and Texas. An interesting bit of information that we noticed was that of the 42 remaining states, those only account for less than 100,000 installations. So that's less than Arizona. So we're thinking that perhaps there's a lot of opportunity there for installations. And so we wanted to take it a step further and go beyond the states. So what we did was we used the Google Map API to create a heat map visualization. And as you can see, California and the Northeast, there's a lot of installations. There's pockets in Las Vegas and Arizona, Dallas. A little surprised about Florida. Not as many installations as we expected. We zoomed in to the great state of New Jersey, and unsurprisingly, in the Northeast, you can see a lot of installations. They have a high population density, but what was interesting was in Ocean County, we saw a ton of installations. So that was a little surprising for us. So the first question was, where are solar panels being installed? So we just answered that question. The next question is, who is installing those solar panels, and what are the relationships between the census data and the NROL installation data? And Deshan is going to take it over.
Thanks, Michael. Okay. Sorry. Yeah. So yes, I'm going to talk about more of analysis results. Mike has presented the installation data, for each state, but that's the total installations. Here, we actually look at the installations in each state by the normalized the data. We basically look at how many installations per 10,000 people. right? We think that this more reflects accurately, right, how passionate are the people in each state about the solar panels. You can see the number is pretty, is varied, but the top 5 states is Massachusetts, California, Nevada, Arizona, and Connecticut. So we also looked at the installations over the years in New Jersey. You can see the trend is the same as for the whole nation. It increased quickly over the past, especially 10 years. And actually, 2015 saw the biggest increase, 36% from the previous year. Also, this one unique thing you can see. Actually, was a dip in 2013 and 2014. This is not like randomly occurring, and I will come back later in a minute. And yeah, this is the installations for each county in New Jersey, right? We live in New Jersey. We are more concerned about, right, what's going on in New Jersey. You can see the installations also are varied across the counties, and actually the Ocean County stand out, right? The top one. My county, actually, Mercer County, is in the middle. Yeah, we actually look at the changes, the installation change over the years in the Ocean County, right? So the #1 county in New Jersey. You can see the overall trend is similar to the New Jersey state. Again, we saw the dip in 2013 and 2014. So this is interesting. It would be right. It's worth investigating what happened. Right, there must be something happening in that 2 years. So yeah, continually we look at the 3 factors that might affect the people's decision to install solar panels. The one is the population, the community population. Actually, the second is the median age, and also the household income. So this is the data for the population versus installations. You can see we did the linear regression, and also the correlation coefficient is R, right? It's 0.45, suggesting a weak positive correlation, right, between the population and the installations. So then we did a more detailed analysis on the population effect. The data were split into 3 groups based on the population, right? The first group is below 40,000 population. The middle group is between 40,000 and 70,000, and the third group is above 70,000 population group. Then we calculated the mean installations for each group. You can see both the middle populated and also the high populated communities have more installations than the low populated area. Then we also did the statistical tests, right? The ANOVA test, we got p, right, very low p values, suggesting the mean installations are significantly different across the 3 groups. Then we did the 2 sample paired t-tests for the 3 groups. Well, you can see actually the middle and also high populated area. Definitely the mean installation are significantly different from the low populated area. But for the middle and also highly populated the groups, the mean installation is not, the p-value is 0.07, is greater than 0.05, right? It's not significantly actually different. So this is the age factor, right, versus installation. So again, we did the linear regression. You can see it's the R, right, value is negative 0.17. So maybe it's a very weak negative correlation, well, if you say there's any. Then we also look at the data in more detail by splitting the data set into 2 age groups. The younger age group is below 45 years old. The older group, right, is about 45 years old. So again, we calculated the mean installations. You can see actually the younger group has 2-fold and a half of the installations in the older group. actually the t-test show the difference is significantly different, right? The difference is true, is real. And the last factor is the household income, right, versus in installations. So again, you can see, well, the linear regression, maybe the R value is close to 0, so almost no, right, linear correlation. So we submitted, we split the population, the household income, right, into 3 groups. The one group, the lower income group, is below $40,000. The middle income group is between 40,000 and 120,000. The third group is above 120,000 group, right? You can see the mean installations. Actually, the middle and the high income groups, right, has more installations than the low income groups, right? That means more income means more installations. But the ANOVA test, shows a significant difference. The 3-paired, right, t-test showed actually the middle and high income groups, the mean installation are significantly higher than the low right income group. But the middle and the high income groups, the difference is not significantly different. Okay, so I'll pass it to Evan, so he will walk you through the Jupyter notebook.
Thank you. So let's travel to a universe far, far away and look at our code in Jupyter Notebook. Okay, so we have our dependencies. We have our imported data. I'm just going to go through this quickly at a high level. We have our data frames with all the merged information. Then we have our solar panel installation trend and the graph. Installations by state and the graph. Our exploratory analysis, where we could go a little bit further. Our New Jersey information. Then our normalized data, population analysis with our charts and regression. And then we have the statistical analysis, the ANOVA, and the t-tests that we did. So our main takeaways. Solar panel installations continue to be on an upwards trend. The majority of installations are taking place in 8 key states. We also notice that the greater the population, the more likely installations are going to take place in that location. People 45 years old and younger are more likely to install solar panels than 45 and up. And those with income between $40,000 and $120,000, generally in the middle class, are more likely to have solar panels installed. So our next steps would be market opportunity analysis, as well as understanding how different factors can affect solar panel data and installations in different ways, things such as weather. Our limitations, unfortunately, the data set could be considered incomplete because the submissions are voluntary, and some states have less than 100 installations. Any questions?
So, Deshan, you mentioned at one point there was a dip, I think 2010 or so.
2013 and 2014. Yeah.
So if you told me you were going to tell, what happened there?
Yeah, actually, it will be interesting to know, you're right, in both New Jersey, right, and also the Ocean County, right, we saw that dip. But the nationwide state, we didn't, So we think some unique things happened in New Jersey that affected, right, the installation in New Jersey. But it will be interesting to investigate, but somehow we didn't have time, Yeah, I think, in future, I think it will be interesting to find out.
There's parking Sunday.
Yeah, sorry.
Hurricane Sandy.
Mm-hmm.
Oh, if
That-
someone talk about the Hurricane Sandy, is that in that?
I mean, because you have Ocean County have a lot of installations, and
But yeah, you
that's
know,
Ocean
it might
County.
be.
Is,
it might be it's in
That's an interesting
yeah, that's
point.
interesting.
Yeah.
Right. Yeah.
Any other questions?
Other questions, yeah?
yeah, I think maybe.
We did an analysis where it is very close to the open space area, where very close of the density of the houses.
Oh, yeah, that will be interesting to look at that. But since the data set we have don't have that kind of information, you know. If somehow I don't know how can we get that kind of density, house density, right? Something like that. Yes, data set, you know, yeah, we can incorporate right with our the data set to do that. Yes, the analysis. Yeah.
I had a quick question.
Yeah.
So at one point you did the analysis between the population and
Right.
the solar panels
Right,
installed.
right.
Was there any, any question driving that? Like, yeah.
Oh,
Like-
so can you be
yeah.
more specific?
Yeah,
What
I
kind
mean,
of question?
What were you looking, or were you looking for anything there in terms of, trend or?
Oh, yeah. So basically, right, that's by zip code, right, is the population, you know, so it's from, could be below 40,000, you know, to or above 70,000 population. So basically, you know, we think right, usually more population shows more installations, right, you know. But yeah, so all is true, right? We did the linear regression, you know, got the R value 0.45, suggesting, right, the weak positive correlation. But somehow when the population reached right over 70,000, you know, the installation also was leveled off, you know, yeah.
So that was one of the things that we analyzed from the census data. We pulled in, income, age, population, and we analyzed that against installation count. So,
Right.
just to see if there was any type of unique relationship with it, and it turned out to be of the three, right, that had the strongest.
Right, yeah.
So.
Were you looking for any incentives or tax benefits that were offered by the particular states or anything?
That's a good question. We were a little pressed for time, but that's something that we would do in our next phase.
Yeah.
Unfortunately, the data that we had incomplete information when it came to rebates and tax refunds and stuff like that.
Yeah.
So we had to kind of admit that.
Yeah, actually, in the original data set, there is this incentive column, you know, but we have limited time, you know, we just focused on the installation counts, you know. They also, you know, like how much energy generated, you know.
Oh, yeah,
yeah.
that would've been
But
interesting.
yeah, that, you know, yeah, we don't have that much time to do all this. Yeah, that will be interesting, yeah, to look at.
All right, let's thank our speakers again.